So Unit 4, Lesson 1. Okay, I know it says Lesson 4, but we're starting with slope of a line segment for our first lesson of this unit. A trucker driving up a hill with a heavy load may be concerned with the steepness of the hill when building a roof. A builder may be concerned with the steepness of a pitch. A skier going downhill may be concerned with the steepness of the ski hill. In mathematics, the term slope is used to describe the steepness of a line segment. In general, slope of a line segment can be recognized as rise over run. Okay, what I suggest to do if I was you right now, go ahead and put on the rise, put up or down, because we go up, we go positive, down, we go negative, but always run to the right. It kind of makes things less confusing, because when it says you can go to the left or you can go to the right, just always go to the right unless you're trying to get an extra point, and I'll explain what that means. People get really confused on this because it's saying to do two different things. Positive, we go up, negative, we go down. Positive, we go right, negative, we go left. The reason this can be confusing is if I say, hey, Travis, you have -3/4. He's going to be like, oh, that means I go down and left because I have a negative, right? But if I go down and left, that's two negatives, so it's a positive, right? Okay, does that make sense? So I don't really like doing that, so I like keeping this always to the right unless we're trying to get extra points, and I'll explain the extra points part. So as long as you're going up or down for positive, negative, the rest will be good. Questions? Okay, so rise or run. So here we go. This says each line segment on the grid has endpoints with integer coordinates. Complete the table below. So AB, what's the rise? So from AB, it goes 1, 2, whoops, just 2. Right here, it just goes 2, so we write 2. The run, 1, 2, 3, 4, 5, 6, 7. 7. So the slope is 2/7. 2/7. C and D. Up 1, 2, 3, 4, 5. So up 5. Over 1, 2, 3, 4. 5/4. Yes? 4/5?
No, like so you get a negative.
Okay, so good question. So we need to understand you start from the farthest point to the left. Because if you start from here, you can still do it. Because it's going to be down to the what? Left. If I'm going down and left, it's both negative. So you can do that. If you want me to write that, that's fine. That means we went down 5. So she's saying, what if I went down this way and that way, right?
Yeah.
So that would be down 5, left 4. So these would both be negative, which would be a positive. I typically know this line, I just look at it, guys, and you should too, it's going up. It's got to be positive. And when I'm doing my lines, I always start with whatever point's farthest to the left. Even though this is CD, I can get the slope from here to there. I don't have to start at C. Okay, because this line will have the same slope whichever point you start with. So for example, if I started with B, I would have went down to left 7. Negative, negative. Okay, it's the same thing. Does that make sense?
Yeah.
Great question. Okay, EF. So now this one, if I start far to the left, which is which one? The E. Now I have to do what? 1, 2, 3, 4, 5 down. I have to do negative. But then I go to the right this time. 1, 2, 3. So the slope of this one's -5/3, which makes sense. It's a downward line. Okay? Negative, positive, positive. Questions yet? Feeling okay? Okay, so investigation number 1. So it says complete the chart, write the slopes in simplest form. AB. They did this way, so it's 1, 2, 3. 1, 2, 3. I think it's 3 and 3, isn't it? Oh, just 2. You're right. Just 2. Thank you. It's 2 and 3. So this is 1, 2, 1, 2, 3. Okay, so slope of AB is 2/3. Now do AC. So you got 1, 2, 3, 4, 5, 6, 7. No, I miscounted. These dots are really tough to see, aren't they? 1, 2, 3, 4, 5, 6, 7, 8. Everybody got 8? And then the 2, so the rise is 8. And now I'm going to do the run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 8 over 12 is my slope, but what does that reduce to? 2/3. Right? 4 goes into 8 twice, 4 goes to 12 3 times. All they're showing you here, okay, I'm kind of spoiler alert. They're showing you that no matter where you do the slope of the line, it's the same slope everywhere. So like this line, this is a line. We're finding the slope at 3 different points. All these slopes should be the same. If we get different numbers, we're doing something wrong. Okay, because slope has to have the same slope the whole time. So 13, 14, 15. 1, so this one's run of 15. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 15 also reduces to 2/3. And last one, BC. I know this is kind of tedious, but here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I get 9 for my run. And then up here, 1, 2, 3, 4, 5, 6. 6 over 9. Again, 2/3. So also we just proved there, guys, that if you ever get a graph, you guys can count from anywhere. Wherever you want to count, whatever is easiest for you to see, you can get the slope from there. And it should be consistent throughout the whole line. Okay? Any questions there? Okay. All right, the slopes of all line segments on a line are equal. That's what we just proved. The slope of the line representing the graph of a linear relation can be found using rise over run for any 2 points in the line. So any 2 points. Go down from here and here. Go down from there and there. Doesn't matter. I can get the slope from any 2 points. Investigation 2. This is a very, very, I won't say very important, but people often forget this, and it's very easy if you can remember. Okay? So consider line segments here. So determine the slopes of all lines in grid 1. So what's the slope of these? If you have me for Math 9, I use a little bit morbid way of describing it, if you remember. Yeah, if you're dead, you're flatlined. You don't have a heartbeat, right? If you don't have a heartbeat, that means you have 0. These are flat lines. Unfortunately, these people are not alive. Okay, 0 heartbeats. Okay, does that make sense? So flat lines, slope is 0. Okay, so the slope of all these segments is 0. Another way of doing it, it's rise over run. How much rise do I have? None. I'm not rising at all. I'm just moving, I'm just running. So it's 0 over like whatever, 6. What's 0 divided by anything? 0. Okay, flat lines, that's the definition of why they're 0. Okay? Now, the vertical lines is the confusing lines. Nope. 1 is up 1 over 1. Good question, though. So she said 1. 3 is not 1. It's because 1 is 1 over 1, so this would be up 1 over 1. That's what 1 looks like. 0 over 1. Nope, that's what this is. 1 over 0. Close. You are correct. 1 over 0 is why are you guys saying 1, though? 0.5 over 1. Well, guys, we go to the point where it's at. So it's rise over run, right? We know it's rise over run. So we have a bunch of rise here. right? We have, it's rising, but where's it rising at?
Through 0.
This one's through -2. This one's through 3, right?
Close enough.
Okay, but these are line segments, so it's going 1, 2, 3, 4, 5, 6, 7. The rise is 7. The run, it doesn't run. 7 divided by 0, is that possible?
0. It equals 7.
Do your calculator right now. Everybody your calculator, what's 7 divided by 0 tell you?
7.
It's error.
Error is correct. You cannot do that. You can't divide by 0. This is the reasoning. This is why. Slope is a tilted line. Correct? This one's not a tilted line. It's so steep, it's straight up and down, so therefore it does not have a slope. It's undefined. Okay? It's so steep we can't define it. Because a slope means it's tilted. Well, this isn't tilted, it's a vertical line. Okay? So it has no slope. But not 0, it's no slope. So it's undefined. If you want to put a little parentheses, because we can't divide by 0. Complete the following statements. Horizontal line segments have a slope of 0. Vertical line segments have a undefined slope. People often get these mixed up. Questions? Nope. All right. Investigation 3. Each of the lines in the grid passes through at least 2 points with integer coordinates. Calculate the slope of each line. So remember, rise positive, we go up, negative, we go down. Remember, we're not going to do the right, left, we're just going to always go right. So what I want you to do is, and this is a very important tool, to be able to find a slope of a graph, you need a what type of point. And I'll see if you can get the word that I'm thinking of. But when I'm looking at this graph and I want to count, what do I need to count from? Do I want to count from right here? Here? Yeah, I call it a smooth point. So Lauren's on it. See how this one right here goes right through that coordinate? See how it goes smooth? If I do this one, is that smooth? No, that's not. Do you see what I'm asking for? Smoothly through a corner. Is that better?
Yeah. And can you start on a different one?
Yeah, you can find any one you want. I found this one, and then I'm going to go to this one. Those ones are smooth points. And now I'm going to count from there. It's up 2 over 3. So line 1 is 2/3. Okay, I'm going to give you a second. I want you to try to find the rest of them, and I'll be right back. You guys did here. All right, so for line 2, let's see, this one's smooth, and this one's smooth. 1, 2, 3, 4, 5. 1, 2. So I got 5, 2. So line 2 is 5 over 2. Below, is it asking you for them? Okay, so you guys fill them out down there. Okay. How about line 3? What'd you get for line 3, Logan? Huh? Undefined?
I got 1/3.
What? Definitely tilted. This one?
Oh, I got 1/3.
Yeah, 1/3. Up 1, 1, 2, 3. Guess that's what you get for asking me where I went. Called karma. Okay, so you can see all these ones, guys, were positive. All these ones are negative. Okay, so again, line 4, smooth spot there, smooth spot there. Down 1, 2, 1, 2, 3 to the right. That's -2 and 3. I guess it doesn't matter, but typically might as well do the one on top first, right? Because it's rise over run. You got positive what?
Ridge, you drop something.
Does it matter what side you're on? Is it just if you're going up, it's always positive? You just have the negative side.
So I guess explain to me what you did. Did you go this way?
Yeah, I went 3 across and then up a 2.
Down the wall.
This way? Okay, so then the only problem with that is, since it's rise over run, you're going to have to make sure that you put the rise and the run in the right spot. So she's asking, so Lauren, did you do this? Did you have 2 over negative 3? See, you put the 3 on top. The 3 is not the run. The 3 is not the rise. Do you see what I'm saying? So you have to put the up and down movement on the top because it's the run. So if you started here, you're fine. You went left 3. Okay, you went left 3, so that's negative 3, but that's the run. It's on the bottom. The rise of 2 should be on top. And so you still have negative 2/3 if you do it that way. But if you put a 3 on top, you're not doing it correctly. Is that good? Okay. Guys, these are great questions. You guys are driving the class today with your questions. Keep it going, please. Except for Logan. Okay, that's a smooth spot. That's a smooth spot, and that's a smooth spot. 1, 2, 3, 4, 5 down. 1, 2. Negative 5 over 2. That's right. Determination, adversity. Okay. Smooth there. And there. Down 1, 1, 2, 3. Line 6, negative 1/3. We doing okay? All right. So you already filled all those out. We just did all those there. Compare the slopes of 1 and 4, 2 and 5, 3 and 6. They're all what? Opposites, right? Weren't they negative of each other? Yeah. Okay. So opposites, just write opposites here. Complete the following statement. A line which rises from the left to right has a positive slope. A line which falls from left to right has a negative slope. So it means this, this. Okay, on we go. All right, so a grid has been superimposed on the sketch here. Estimate the pitch slope of the roof to the right of the worker's head. So we're trying to figure out what this slope right here is. So best thing to do, find a smooth spot that you can find for the roof. Or roof, whatever you want to call it. This one? Wait, oh, the second line? Yeah. That one?
No, like the so like the top of the I thought third from the top and the first from the top. Yeah.
Third from the top.
Wait, what line are we doing?
It doesn't matter because this, like right here, this is the slope, like the.
First line you just did. The first line highlighted.
Okay, you want to look at that one? Oh, I see. Like this one?
Yeah. The second.
Okay.
I went up one.
Okay, so we'll take that one.
Yeah, that's.
Okay, and then this one. So these lines follow cleanly. So that would be up 1 over 3, right?
Well, there's another line, like there's some point that you can go to.
Yep.
There's
No,
another.
you guys are all fine, but listen, this whole thing's the same, right? So you guys said there's another one. That's fine. Up 1, 1, 2, 3. Up 1, 1, 2, 3. So yeah, we just confirmed it's 1/3 for both of them. So we're good. Okay. So it says estimate. So we would estimate. Let's just say we did 1/4. Not get too cocky there. I'm just kidding. We'll just put 1/3. Okay. Could the grid be used to estimate the pitch of the roof of the worker standing on? Yeah, it's not the right perspective. I'd say no. It's we don't have we would need to turn it here. So it's the wrong angle. Okay, look at example 3. Okay, draw a line segment on the grid which passes through the point negative 4 over 2 and has a slope of negative 2/3. This is what I said before on the board. You should be able to do quickly. Okay, find the point negative 4, 2. That's your first step. 1, 2, 3, 4, 1, 2. That's the point they want. The slope is negative 2/3. Down 2, right 3. If you want more than one point to help you have a straight line, do it again. You can see they line up. Draw your line. So there's our line. Everybody comfortable with that? A line segment has a slope of -5/7 and a rise of 12. Calculate the run as an exact value. So what are they making you do here? No, you're kind of right, but they actually, if it's -5/7, a rise of 12, they're making us do equivalent fractions. So you have to cross multiply. Okay, we don't need to worry about the negative right now. It's going to be 5x equals 84. You divide 5, so it's going to be a fraction, which kind of stinks, but 84 over 5. 84 over 5. Okay, let me make sure that's what they want us to leave it as real quick. All right, so what we did is that we know, like the problem we did earlier, we did 2/3 is the same thing as 6/9. 2/3 is the same thing as 6/9 for slope. They're equivalent fractions. We want to figure out if our slope's -5/7, how far over do I have to go if I'm going to go up 12? And so what we did was we cross multiplied. I said, don't worry about the negative for right now. We went up 12. So if I go up 5/7, that's my slope. But if I go up 12, how far do I have to go to make sure I stay in line with my line? Okay, not 14. Okay, it's going to be 84 over 5. So what that means is, who knows what that means actually? I'll ask you first. Okay, hold on real quick. Yes, you're right, Lauren, but I want to tell you something here. Guys, notice this is smooth, right? This is smooth, right? What about this one? No. This answer is not smooth. If I go up 12 and over, I'll hit the line at not a smooth spot. That's what this means, why we don't have a whole number. So you're saying, why isn't it whole? Not all of them are whole. This isn't whole. That's not whole. That's not whole. Those are all decimals where they cross. Okay, let's try this again. But no, I do want this. That's fine. Smooth, 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 smooth. Okay, all those points there are your whole number points. This line has an infinite amount of points. This, not smooth. Not smooth. These are all decimals or fractions. Okay? So, if I have a slope of -5/7, let's just talk about what that looks like. We'll just say it's at 0 for a second, okay? So I go down 5 over 7. So I go down 5 over 7. That's what this line looks like. Okay, if I went up 12, I would have to go over how much? 84. Yeah, it's off the page. It's going to be this, and it's a negative because we're going to be going to the left. How do we figure that out? Well, this is what we have to figure out, guys. We talked about, let's erase this and we'll do it again. We talked about if this is my slope and I tell you you're on the same line, you went up 12, I have to go over a certain amount to make out the same exact equivalent fraction. All of these slopes are the same from every spot. So if I tell you I'm on the same line, we're not on a different line, it's on the same line, and I go up 12, I can solve to figure out how far I went over. The thing you're not understanding is it's not a whole nice number. So you cross multiply. 12 times 7 is 84. 5 times x is 5x. Okay, and it's going to be a negative because this is a -5. You divide by -5. X would be -84 over 5. So what that means is if I went up 12, I have to go left 84 over 5. That's all it means. Okay, any other questions on that? Don't be psyched out with the fractions. We have done cross multiplication solving before in Math 9. Okay. All right, let's keep going here. Oh, let's go ahead and stop here. Okay, any questions for slope? Okay.